So only on an arithmetic sequence are we worried about negatives and positives. We'll handle geometric in a second. We shouldn't have to worry about it on geometric. All right, to alternate between positive and negative with arithmetic sequence, it doesn't work without this trick. Remember, arithmetic sequences, you are either adding or subtracting the same number over and over and over. So if you look at this, to get from -1 to 2, I'd have to add 3. Well, if I add 3 again, I would get to 5. If I add 3 again, I'd have 8. If I add 3 again, I'd have 11. So this looks like it's not arithmetic. But if I forget about the negative signs, 1, 2, 3, 4, 5, that's just +1, +1, +1, +1. So we need to look past the negative signs and just see the numbers in there. To handle the negatives or positives, we're just going to attach either a -1 to the n or a -1 to the n minus 1 out front. That's going to allow it to alternate between positive and negative. What we're basically going to do is we're going to attach this on the front of our equation, and this will either multiply your equation by a -1 or multiply it by a positive 1, thus alternating between negative and positive. So, for example, if I have -1 to the nth times n, what would my first 4 terms be? Well, if I plug in a 1, if I plug in a 1 for this n and a 1 for this n, I'm going to have -1 times 1, which would give me a -1. My next term would be plugging a 2 in. Well, if I plug a 2 in, our n is going to be 2. This n is going to be 2 as well. Well, -1 squared is a positive 1. A positive 1 times 2 is just going to be a positive 2. If I plug in a 3, -1 cubed is -1. -1 times 3 is a -3. And if I plug in a 4, I'm going to get out a positive 4. So our first 4 terms would be -1, 2, -3, and 4. If I do the exact same thing, but I switch one thing up, that I have n minus 1, we're going to note that the alternating is different. If I plug a 1 into this -1 to the n minus 1 times 1, times n, I should say. Well, if I plug a 1 in, that n's going to be 1, that n's going to be 1 as well. I will now have 1 minus 1. -1 to the 0th power is 1. 1 times 1 would give me a positive 1. If I plug in 2, 2 minus 1 is 1. -1 to the first is negative. That would be a -2. And then we'd have a positive 3 and a -4. What I do want to point out right here is there's more methods to get a -1 out. We could do -1 to the n plus 1. We could do -1 to the n plus 3. We could pick anything, but if I was you, I would either pick this one or this one. It just makes your life a little easier. You just got to find the one that makes your negative your first value or your positive your first value. So if I use -1 to the n, I'm going to get a negative value out first. If I use -1 to the n minus 1, I'm going to get a positive value out first. So when I'm looking at an equation like this, where I have 40, -60, 80, -100, well, I'm going to notice it's not strictly arithmetic. Because once again, to get 40 to -160 would be a -120, but -60 plus a -120 doesn't equal 80. But if you do notice the fact that we do have, I didn't put that on there. Move. I don't want to think about, we're going the wrong way, that's why. There we go. I don't want to think about this as being 40, -60, 80, -100. I need to think about an arithmetic sequence that's 40, 60, 80, and 100. That's the arithmetic sequence I need. I'm just going to tack this on in front of it. So we're going to do all the steps to get a 40, 60, 80, 100 arithmetic sequence. That is, this is plus 20. This is plus 20. This is plus 20. This is definitely arithmetic. So our arithmetic sequence is going to equal our first term plus n minus 1 times our common difference of 20. This is our arithmetic sequence. Well, if we just go ahead and simplify that, that would be 20n. 20 times negative 1 is negative 20 plus 40 is a positive 20. That means my official equation is going to be a sub n equals, leave a little space, but it'll be 20n plus 20. I should have given myself just a little bit more space. Now what I need to do is I need to attach one of these to the front of it. So I need to have a negative 1. Should have given myself even more space. I'm going to give myself more space. So I need to either have negative 1 to the nth, or I need negative 1 to the n minus 1. Well, I'm going to look here, and I'm going to say the first term needs to be positive. In order for the first term to be positive, I need to use n minus 1. So we're going to make this n minus 1, and that's going to be my equation. Negative 1 to the n minus 1 equals that 20 times n plus 20. The 20n plus 20 is going to tackle the 40, 60, 80, 100. The negative 1 to the n minus 1 is going to tackle the alternating positive and negative. That means if I had to come up with the equation for b, it's going to be almost identical. Except for b, I need the first term to be negative. So I'm going to go a sub n equals a negative 1 to the nth. N minus 1 is going to be my first term is positive. N is going to be when I plug a 1 in. Negative 1 to the first is going to be negative. Now we just throw the equation in, that 20n plus 20. And now we tackled the other negative values. You do not need to memorize which one of these comes up with your negative first and the positive first. You're just going to plug a 1 in and you're going to check. So on the test, you just need to know it's negative 1 to the n or negative 1 to the n minus 1. It could be negative 1 to the n plus 1 as well. What you need to do is you just need to check. Plug in 1. Do you get the positive out or do you get the negative out that you want? And once you check your first term, all the other terms will work as well. All right, that's how we're going to tackle alternating between positive and negative if it's an arithmetic sequence. If it's geometric, don't worry about it. If you worry about doing this with the geometric, your problem is going to be more complicated. I'll show you both cases, but you should only do one thing. For geometric, you should not worry about alternating between positive and negative. In a geometric sequence, it's already taken care of. So if I have 2, negative 6, 18, and negative 54, method 1, preferred, it's the one we did on Friday, where we say, okay, let me put the thing up there. So we have 2, a negative 6, an 18, a negative 54. Well, this is not arithmetic, because even if I pull away the negative signs, I'd have to go 2, 6, 18, 54. There's no way to do that through arithmetic, so this must be geometric or neither. Well, for geometric to work, we need to multiply a number. We are allowed to multiply by a negative. And if you'll notice, each of these are multipliable by a negative 3. So my geometric sequence would just be a sub n equals my first term times my r value to the n minus 1. And you are done. Method 2 is basically, you remember your arithmetic sequence, that when I alternate between negative and positive, I can tack a negative 1 to the n or negative 1 to the n minus 1, and you apply it to everything. That's what method 2 is. Try not to do method 2. It's just if you're on a test and you just see alternating and you automatically put a negative 1 out front. Method 2, once again, not preferred, would be I drop the negative sign at first. So I think of this as being 2, 6, 18, and 54. And then I think about my r values just being times 3. Well, that would give me an equation that looks like this. First term, r value, n minus 1. Well, I need to tackle this alternating between negative and positive. So if I use one of those negative 1 to the n's or n minus 1 values, would mean my actual value, so it can alternate between positive and negative. I need my first term to be positive. So I'm going to use negative 1. First term is positive. If I plugged in just n, and I plug a 1 in there, negative 1 to the first would give me negative. That's not what I want, so we'll either go plus or minus 1. And then we go 2. Maybe I should put those in brackets. That's too many parentheses. 2 times the 3 to the n minus 1. Both of these two equations will satisfy this sequence. One is a lot easier, and one takes a lot more steps. That's why this is by far your most preferred method. When you are dealing with alternating between positive and negative, check to see if it's geometric first. If it is, you don't have to worry about the alternating. If it isn't, and it's arithmetic, that's when we need to attach those negative 1 to the n or negative 1 to the n minus 1. So not preferred. Preferred method is just realize that, hey, in geometric, I don't have to worry about it. I can multiply by a negative value, and it will alternate on its own. So geometric does it on its own. Arithmetic, you need to put that negative 1 to the n or negative 1 to the n minus 1 out front. All right, next thing, our fractions. Now, we've already dealt with some fractions, but I'm going to deal with fractions that aren't necessarily strictly arithmetic or geometric. So in these cases, sometimes we'll see a solid numerator, a solid denominator, or we might see a sequence on top, and we might say a sequence on bottom. So what we are allowed to do is we're allowed to think of these as being two separate sequences if we need to. We could think of A, C, E, whatever, being one sequence, and we could think of the bottom as being another sequence. So I'm thinking we have a numerator sequence and a denominator sequence. So I'm going to write an equation for the top, and I'm going to write an equation from the bottom. So for example, we have this 1/2, 1/4, 1/6, 1/8. Well, I could start thinking about this as being geometric. If it was geometric, I can multiply by one number. Well, if I multiply 1/2 by 1/2, I get 1/4 out. If I multiply 1/4 by 1/2, I get 1/8 out. Well, that doesn't work. It's also not strictly arithmetic. There's nothing I can add to 1/2 to get to 1/4. That will also get me to 1/6, but it will also get me to 1/8. So what I'm going to treat this as is every one of these has a 1 on top. So I'm going to have some kind of equation that has just a 1 on top. And if I look at the bottom, I have 2, 4, 6, 8. That's arithmetic. That is arithmetic. So I'm looking at this bottom one, that 2, 4, 6, 8, and I'm saying, well, that's arithmetic. To get from 2 to 4, I'm thinking that's plus 2. To get from 4 to 6, that's plus 2. To get from 6 to 8, that's plus 2. So if I'm just looking at the denominator, I can write an arithmetic sequence. That arithmetic sequence is going to be, okay, first term plus n minus 1 times my common difference. Factor that common difference, I'd have 2n. 2 times a negative 2 is negative 2, plus 2, that's 0, that's plus 0. I don't need to put a 0 there, it's just 2n. So my denominator is 2n. So what we're going to do is we're going to write this equation as a sub n equals. Every one of my terms has a 1 on it, so I'm just going to put a 1. That will satisfy all of those. On the bottom, it's going to be a 2n. So once again, I have a sequence where I talk about the numerator, I talk about the denominator. My denominator was arithmetic, so I have a 2n on the bottom. On top, it just stays 1. If I look at my next one, I have 1/8, 2 over 4, 3 over 2, 4 over 1. We don't have room to try this, but I'm just showing you that one method on this one, once again, don't write this down, would be to try to come up with a common denominator, which would be, what we have? We have 4 over 8. We would have 12 over 8. We would have 32 over 8. So it doesn't quite work out that I have a geometric or arithmetic if I do that. So then I go back to the drawing board and I look at my numerator and denominator. My numerator goes 1, 2, 3, 4. Well, that's arithmetic. That is plus 2, not plus 2, it's just plus 1, plus 1, plus 1. And in my denominator, to get from 8 to 4, I'm dividing by 2, which is really multiplying by 1/2. This would be multiplying by 1/2. This would be multiplying by 1/2. So what I have here is an arithmetic in my numerator and a geometric in my denominator. So we're going to treat it as such. I'm going to come up with an equation for my numerator. I'm going to come up with an equation for my denominator. So my numerator is going to equal an arithmetic sequence. Arithmetic sequences are first term plus n minus 1 times your common difference, which is 1. My numerator, that's going to equal your first term, which is 8, times your common difference, which is 1/2, to the n minus 1. So I need to know my arithmetic sequence. I need to know my geometric sequence. And now we're just going to write it as a fraction. So we can just put a fraction bar over that. So our equation is going to equal, well, if I simplify that, we'd have 1n minus 1. So we just have 1n on top. That would just be n. On the bottom, we'd have our 8 and 1/2 to the n minus 1. That's our equation. I got an arithmetic on top. I got a geometric on bottom. So if you really struggle, if you can't see something's arithmetic or geometric, and I told you have to write an explicit formula for it, double check to make sure you don't have a fractional equation where the top can be accounted for, the bottom can be accounted for, or maybe the top just stays the same. That's a good sign that it's going to be one of these, is the top just stays the same. All right, so those are fractions that don't look arithmetic or geometric, but actually are, as long as you break it down into parts. All right, the last thing we're going to talk about is just a special case. These are exponential ones. Not exponential, but exponents. Some explicit formulas will use exponents, but will not be considered geometric. So if I look at 1, 4, 9, and 16. Well, 1, 4, 9, and 16, 1 times 4 is 4. 4 times 4 is 16. I got to account for that 9. I got to account for that 9, so that is not geometric. It's also not arithmetic. You can't just add 3 over and over and get to all of those. So this is going to be something different. So if I just break this down, and I say, okay, my first term is 1. My second term is 4. My third term is 9. And my fourth term is 16. There's something happening here. Well, 1 becomes 1, 2 becomes 4, 3 becomes 9, and 4 becomes 16. What am I doing to all of those numbers? Yeah, I'm squaring them all. So if we look at that, 1 is actually just 1 squared. 4 is 2 squared. 3 is 3 squared. And 4 is 4 squared. So if I gave you an a sub n, you would say, okay, well, this is 1 squared, 2 squared, 3 squared, 4 squared. A sub n is just going to be a sub n equals n squared. And that will tackle that. It's not geometric, it's not arithmetic, but it is one you need to be able to recognize. You need to recognize when these numbers are being squared. So if I tell you have to find a sequence for something, write it out and see if there's a pattern with these numbers. Because sometimes it might be 1 squared plus 1. It might be 2 squared plus 1. It might be 3 squared plus 1. It might be 4 squared plus 1. You just got to play around with it. All right. That's all I got for these. Do you have any questions? So those are our special cases. Those make it a little bit more difficult when I ask you for a formula. All right. The rest of the time is yours. It does say write a general formula. A general formula means explicit, which means for every one of these, you will be able to write a formula down. Do not put, it's not geometric, not arithmetic, so I don't need to. You need to come up with an explicit formula for every one of these. Every one of these is solvable.